My name is Dil Tavaraja. I'm a professor at the Clemson University. I oversee the Organic Pulse Breeding Program. Today, our guest speaker, we host Going Organic seminar series, and today our guest speaker is Dr. Erick Boy. Dr. Boy, I'm going to get the bio. I'm sorry. Dr. Erick Boy is the chief nutritionist of the HarvestPlus Bio-Fortification program at the EFRI. He completed his medical studies, MD, at the University of San Carlos in Guatemala, and his PhD is in human nutrition at the University of California, Davis. Dr. Boy's career has been over 30 years conducting and managing food and nutritional research at the global agencies like Institute of Nutrition Center America and Panama. And also he's the leader of the Micronutrient Initiative. And also I have worked with him on the HarvestPlus program, the first one to do the biofortification of staple food crops to combat hidden hunger, micronutrient malnutrition for the low and middle income countries. He has a very impressive CV, and he has been the global leader of the micronutrient malnutrition, combating these issues, global issues with the staple food crops. And it's my great pleasure to introduce Dr. Erick Boy.
Well, thank you, Dil. Good morning, afternoon, evening, everyone. Thank you, Dil, for the invitation, and Tristan for making all the arrangements. So today, it'll be my pleasure to try to summarize what is really a 30-year history of biofortification of staple crops to improve human nutrition in developing countries.
1 minute, Erick. You want to share the screen with the one slide, because right now we can see two slides. Do you want it to go display settings?
Display settings again.
I'm sorry.
That's okay. Now?
Yeah. There you go. All right. Thank you, Erick.
You're welcome. Thank you. So that's the topic of today's presentation. I hope I can summarize correctly to give the intended message. But I will start with a disclaimer, and that is that biofortification is not conceived or implemented as a panacea, as a golden bullet fix at all. It is meant to be a complementary intervention that should be combined context specifically with supplementation, large-scale food fortification, and of course, never losing sight of the ideal, which is dietary diversity. But while the food prices continue to increase and this dietary diversity becomes more affordable, the implementation of the interventions that I just mentioned in a combined manner, along with public health interventions to prevent micronutrient deficiencies, is the suggested way forward to prevent micronutrient deficiency sustainably. And of course, biofortification can be achieved in different manners, by genetic bioengineering, transgenic, isogenic, genome editing, also by application of conventional fertilizers or nanoparticles is the new wave in fertilization. And most recently, the regenerative agriculture movement has come up with microbial fertilization or manipulation of the microbiota of soils to improve uptake of micronutrients in plants. Both staple crops as well as cash crops can be biofortified. But I'm going to talk only about the achievements and the way to scale up of conventionally bred staple crops. And why is tackling micronutrient deficiency important? Well, we're not sure of how many people around the world are affected, but usually you hear more than 2 billion people live with micronutrient deficiencies. And a publication 2 years ago in the Lancet Global Health, using limited data from about 12 countries, came up with these figures. 370 million preschool children and more than half of women of reproductive age have at least one of six micronutrient deficiencies, with vitamin A, zinc, and iron, vitamin D, B12, and folate being the micronutrients that this group could look at. So, around 2 billion women and children around the world are affected by at least one of these micronutrient deficiencies. And a more recent estimate of what the food supply, if you don't include the nutrients added by large-scale fortification or biofortification, the food supplies that are available, accessible currently worldwide, mean that at least 5 billion people do not get enough iodine, vitamin E, or calcium. Second tier micronutrient intake inadequacy is for iron, riboflavin, folate, and vitamin C, with more than 4 million people not getting enough in their daily diets. And zinc is about 3.5 billion people not getting enough in their diet. And I want to repeat that in this estimate, the nutrients added through large-scale fortification were not included. And the fact that a lot of what we are calling iron deficiency anemia is being revised and is not really caused by iron deficiency alone or at all. We're still using anemia as an indicator of iron deficiency, but these dietary indicators usually come up with inadequacy figures or prevalence higher than what you get when you use biomarkers like hemoglobin as a proxy of iron deficiency. Even if we're not sure of the exact number of people affected by macronutrient deficiency around the world, we know that these deficiencies mean a large economic loss to countries with large populations and with a high burden of micronutrient deficiency. You can see in this slide that India is estimated to lose $12 billion of the GDP every year because of micronutrient deficiencies. And in this estimate, only vitamin A, iron, and iodine were included. But large losses of money that could go to a better use in developing countries. And so why does biofortification as an intervention, many times called a nutrition-sensitive intervention, make sense? Well, first of all, the very obvious, because staple crops are at the foundation of food systems, especially for middle and low-income countries. The price of staple crops per calorie is the lowest if you want to use it as an intervention. And as you go up the pyramid into food dietary diversity or post-harvest such fortification or supplementation, you see that the price per individual reached is higher. So staple food crops are at the foundation of the food supply or the food system if you want to change the conditions that are leading to micronutrient deficiency. And not only is it cheaper per person reached, but the cost on the return on investment in terms of disability adjusted life years saved for every dollar that you spend on biofortification is very favorable compared to supplementation or fortification. And so here in the bar graph, you see the dark green bars are the cost per DALI saved associated with biofortification, which is at the lower end. And all of or most of the dark bars or biofortification interventions are below the World Bank threshold for cost effectiveness, which is $270 per DALI saved. And of course, this cost return on investment or cost effectiveness will vary according to country, crop, or number of crops being rolled out. So the narrative part, the text part of this slide describes situations of a low uptake, 25% coverage, versus high uptake, 50% coverage for biofortified crops in different regions. And you can see that the number of dollars invested per DALI saved is always below $35 or $40. So it is highly cost effective, and that's why it makes sense to add it to the the interventions that countries are implementing to prevent micronutrient deficiency. Biofortification, especially with minerals like zinc, iron, calcium, also makes sense because if crops have a higher nutrient content, the impact that increasing CO2 levels will have on these nutrients in many of the staple crops will be buffered, meaning that if you start with wheat at 35 milligrams per kilogram of zinc, the impact, estimated impact of CO2 levels will be relatively, or in absolute terms, lower than if you start with 25 micrograms per kilo, as the conventional varieties of wheat have zinc concentrations in around 25. So it is estimated that CO2 will result in a 3 to 17% decrease in zinc and iron in many of the staple crops. And this could mean about 4% less dietary iron in countries with greater than 20% anemia. And so CO2 level will decrease iron and zinc and calcium and protein in many of the crops, and biofortification can help buffer this effect. And to me, since I have been leading the research in this area, it makes sense to implement biofortification because it works. Multiple efficacy and effectiveness trials have shown that when these crops are consumed regularly as staples, the increase in micronutrients that plant breeders have achieved does result in significant impacts on human nutrition and health. And the oldest and better known story has to do with provitamin A crops, and that is cassava, maize, and orange flesh sweet potato. The trials with these crops in Zambia, Uganda, Mozambique, Kenya, and Nigeria all show improvement of vitamin A status, and in some cases, improvements in functional indicators of vitamin A status. Like in Zambia, children who consume vitamin A maize or provitamin A maize had better adaptation to dark environments. They had better pupillary adaptation to decreasing light in the room. So night blindness, in other words, would be is being prevented at subclinical level. Maternal breast milk in Zambia was also improved, and in the large Mozambique effectiveness trial, diarrhea decreased with orange flesh sweet potato among children under 5 years of age. So vitamin A crops, all the trials have shown an improvement in status and functional biomarkers. And in terms of the iron crops, which really are the high iron beans and the high iron pearl millet, and the Philippines rice was included here because it was a proof of concept trial, but rice itself doesn't have enough iron variability to biofortify effectively. Nonetheless, Julia Finkelstein did this meta-analysis with the 3 iron crops, and she found that consistently iron reserves, serum ferritin increased, total body iron also increased significantly, and hemoglobin increased in those individuals that started the trials with low hemoglobin levels. So iron crops also effective and efficacious in improving iron status, but beyond improving iron status, the Rwanda and the India trials with beans and pearl millet respectively showed that cognitive performance was improved among those individuals that consumed the biofortified crop. So among Rwandan female university students, attention and memory improved as the iron status improved with the high iron beans. And in Indian school children, we saw the same effect, improved memory, attention, and less sedentary activity. In Rwanda, the students demonstrated a greater work efficiency on their standard work conditions using bicycles with weighted pedals and oxygen consumption measurements. So the biofortified crops that contain more iron result in all of these benefits. When we come to the zinc crops, though, we have a problem with the biomarkers not being sensitive enough to dietary level interventions like biofortification would be. Nonetheless, in Bangladesh, a 9-month trial with children under 3 years of age, conducted by ETH Switzerland, demonstrated that there was a very modest but significant improvement in linear growth, length or height, among children who were consuming the high zinc rice. And in this same trial, or the 3 efficacy trials with wheat, plasma zinc concentration, which is the internationally accepted biomarker for population zinc status, didn't change at all. But like I just mentioned, growth improved in Bangladesh when rice was consumed. And in the largest trial with zinc wheat in India, even though plasma zinc didn't move, the researchers, Dr. Sasawal and his team, saw improvement in health. So children and their mothers experienced less days with diseases that are common in this setting. So children had less days with pneumonia or gastrointestinal problems, like vomiting was the key symptom inquired about here. And mothers spent significantly less days with fever. So that means children have more time to thrive, to learn, to interact with their environment, their families, and mothers have more time to dedicate to other activities, productive or just caring activities at home, rather than spending days ill with fever. And all these differences in days spent with disease or illnesses were statistically significant. And this trial included 3,000 household pairs, children and mother, half per group. But I'm a true believer that even though the plasma zinc concentration doesn't change with biofortified crops that contain more zinc, that the results that we've seen in absorption of zinc from maize, wheat, and rice are really encouraging. And zinc is being absorbed from crops at 15% or higher, which is almost the same as non-biofortified crops. And this is an example of the most recent zinc absorption study done in children under 3 years in Bangladesh. The graph at the farthest right shows the total amount of zinc absorbed from conventional rice, the light blue bar, conventional rice plus added zinc, the green bar, and the dark blue bar is the total zinc absorbed from the biofortified rice meal. And you can see that there is a difference of 300 micrograms of absorbed zinc in the children that were consuming the biofortified rice. And this is by itself between 30 or 60% of the physiological requirement of zinc, depending on the reference standard you use, either the European standard or the iZinc standard. So with biofortified rice, one can fill the entire daily requirement of children of this age from absorption studies. So I'm a true believer that because of this high absorption in absolute milligram terms, zinc status can be improved, even though we cannot measure it sensitively with the biomarkers we have. And it makes sense in biofortification because it's cost effective, because it buffers the potential impact of CO2 elevation, because it works as a nutrition intervention, and because the varieties are already there, accessible in many countries. Up to the end of 2023, more than 400 varieties at different levels of biofortification have been released in 30 countries. And more varieties are being tested in pipelines at the CG centers and the national research services. And so you see that we have varieties of pearl millet, beans, wheat, rice, maize, sweet potato, cassava, and maize that can provide anywhere between 40% to 100% of the daily requirement of these individual nutrients for children under 5 or women of childbearing age, non-pregnant, non-lactating. So it makes sense because the opportunity is there, the crops are ready for scaling, and it's up to government, private sector, and everybody, researchers, to continue to push and open the way forward. And the best proof that that biofortification makes sense is that consumers like them. And this graph here shows results for uptake, or how many people are growing and consuming biofortified crops, at least one in 12 countries where we do monitoring of seed sales and crop production. And so by the end of 2023, 100 million people were already growing and consuming these crops. And so we call it on-farm consumption. And our monitoring director, who lives in Uganda, has recently worked out a way to estimate what's our farmers doing with the surplus that they don't consume in their household. And he has estimated that when you add people growing and consuming to the people buying from neighbors or the market, these biofortified crops are reaching around 300 million people annually in these countries where we are doing the monitoring. So we realize that there are more countries that are doing biofortification on their own or have access to the seeds, so the numbers could be an underestimate. And how has HarvestPlus, with its small teams in 8 or 9 countries, been able to get populations to adopt the crops at this scale? And it's a balancing act that is context specific, country specific, not just context, country specific, of using the evidence base that's available, and then we went quickly through it, to advocate for continued testing and production of more biofortified varieties, to create an enabling environment, policies, partnerships, etc., in each country, so that the biofortification is adopted, implemented, and then reaches a larger and larger segments of population. And of course, our focus is the small landholding farmer and the rural communities, but we have to make sure that supply and demand are aligned. And in order to for demand to increase, we have to also work at the commercial end, not just the rural communities, but industry. And so aligning supply and demand is really important, because you cannot promote a product that's not on the shelves, and you cannot demand something that people don't believe in, governments are not supporting. So this holistic approach is based on a value chain focus, from working with the crop research institutes during the pipeline implementation and crop release, to then working with seed producers to make sure that they have enough seed of good quality, and then seed dealers to make sure that the supply is there and that they are selling the product that they say they have. And then with workers, we're working with farmers for best practices in seed maintenance and fertilization if necessary, and all the way to the food processing and retailers. And I will have a specific example of how this has worked in one country later on. of how the value chain approach is really important, because you cannot leave any of these links outside of the intervention. And this long snake of value chain translates into three basic elements that one has to take care of at the country level. There has to be access to high quality seeds or growing material. The production, aggregation, and processing of the produced grain or crop itself for marketing purposes has to be looked after. And we cannot downplay the role of aggregators, because for crops that don't change color and cannot be identified visually, for instance, like high zinc maize or high zinc wheat or rice, I mean, it looks just like the other types of crops available in the market. So aggregators have to make sure that they keep the varieties separate, and so that the impact on nutritional status will not be diluted by mixing, like biofortified beans with non-biofortified beans. And I had a hard time choosing which of the countries where we are most actively working in scaling I could use as an example. So Bangladesh, India, Pakistan. In Pakistan, 40% of the wheat market is now occupied by one high zinc variety called Akbar 2019, and not because of the zinc content, but because of its resistance to rust and its higher yield. So biofortified crops have to be more nutritious, but also competitive, so that the farmers adopt them. And this is something that's usually not understood. People think that biofortified varieties are lower yielding, but no, they have to be high yielding in order for farmers to adopt them. And on top of that, the nutrient trait is added. And so of these countries and some Latin American countries where biofortification continues, I chose to speak about, I chose Nigeria as an example. Nigeria has the largest population in sub-Saharan Africa, and it has high burden of micronutrient deficiency, but also non-communicable disease, right? And so the focus in Nigeria has been to create more business for small and large business undertakers, and also to bring women along and adolescents into the movement of biofortification, of improving food system with more nutritious staple crops. And so in Nigeria, for example, the small team, 5 people, started with creating an enabling environment. And so up until last year, there were at least 12 policy papers that include biofortification as part of the national or state nutrition strategy to alleviate malnutrition in all its forms. So HarvestPlus works with different ministries of Nigeria, and also with donors and public and private companies to create the supply and the demand for these crops. And in Nigeria, we're currently working with high iron pearl millet, most recently, with vitamin A cassava and vitamin A maize. So 3 crops, 1 country, with an enabling policy environment at state and national level. And of course, I spoke about demand, and working with the food sector is very important. In Nigeria, there are partnerships and products on the shelves produced by the larger food companies, and here are some examples. But in order to get to a product that does contain, let's say, more provitamin A come from cassava, there has to be quality control. And in order for the maize produced being healthy, not having aflatoxin in unhealthy levels, quality control is also necessary. So here's where working with the growers and the aggregators is very important to get to a product that can be marketed outside of the farm environment. And the bottom-up approach is also very important in Nigeria. Annually, there is a nutritious food fair where school children come and they compete in knowledge competitions about nutrition. Every year, entrepreneurs come and they share their products, sell their products. Politicians come to give support to biofortification, etc. And Nigeria has also created job creation clinics and smart mother initiatives, increasing the awareness of nutrition, biofortification, but also increasing the role and empowerment that women's groups and the youth can have in transforming food systems. Nigeria has been very active and very successful in doing this. And of course, creating the tools to enable the implementation is important. And here's only one example of a recipe book that instead of using the conventional non-biofortified crops, it uses the biofortified varieties in very savory and nice-looking manners. And so with these recipe books, entrepreneurs have established small restaurants where they only sell one woman in Ibadan only sells food that has at least one biofortified ingredient. And in a couple of the school feeding programs in Nigeria where biofortification has been integrated also includes some of these recipes. And what we can do with these recipes can be illustrated here. And this is an example from not Nigeria, but from a large randomized clinical trial done in Andhra Pradesh by Cornell, Dr. Sora Mehta. And in the green bars, you can see the contribution of the daily menu for vitamin A, iron, and zinc compared to the gray bars, which is the contribution from the non-biofortified menu. So the same menu, the same meals, but substituting the non-biofortified grains or sweet potatoes with the biofortified varieties. And so you can see that the vitamin A supply goes from almost 0 to 500 micrograms if you just add orange flesh sweet potato. Iron goes up just from adding the pearl millet in 2 of the meals of the day. So important contributions to multiple micronutrients, but only through the combination of the crops in the same meals that people are already consuming. So forgive me if I'm going too fast. I lost track of my timer. But in summary, it makes sense to include biofortification at a level of scale that reaches everyone in a given country, because the nutritional evidence is there. These crops, when consumed as staple crops, staple foods, improve nutrition and health, and using the right combination of scaling strategies based on the value chain approach, the number of consumers trying and reusing biofortified crops and foods can actually be very, very large and can be maintained over time. There are challenges remaining, but not unsurmountable. Now that there is no more targeted breeding being paid for at each of the CG centers, they are being given funding now to mainstream the breeding for nutrients like vitamin A, iron, zinc, and there is no HarvestPlus providing the targeted funding for that. There is a risk of diluting the effect, or maybe it'll just blow up out of proportion, and all the varieties of all the staple crops will contain higher levels of nutrients. But somebody has to, within the system, monitor the mainstreaming of biofortification. Integrating biofortification and monitoring its integration in high burden countries where policies are in place is always a challenge because, for instance, I mentioned the aflatoxin problem with maize. That will discredit vitamin A maize or any maize for food products in the future. So that has to be monitored, as all public health and public health nutrition programs have to be monitored for food safety and food efficacy, effectiveness. And there are some research gaps that would make biofortification even more impactful if we had more sensitive zinc biomarkers to demonstrate to policymakers that yes, your investment in zinc crops is reaping a big benefit in health. That would be great. And we are looking into the risk of diabetes as one of the markers of zinc status. And there are publications that actually show that zinc deficiency does contribute to diabetes around the world. And more innovative ways of thinking about how to demonstrate impact to policymakers. The stability of carotenoids after harvest or even in supplements is a known problem. And so breeding for higher stability in the provitamin A crops is also nice to have. Enhancing the bioavailability of iron in beans is something important, and there are some genes that could improve bioavailability. And of course, breeding for multiple nutrients in single crops would be ideal, but this can currently only be done through gene editing or genetic modification, or the combination of crops, as I mentioned before. And of course, we are also now looking into nutrients that make diets healthy beyond micronutrients. So resistant starch in rice, maize, wheat would hopefully help decrease the burden of non-communicable diseases, as well as some antioxidants that are present in some of crops but haven't been really studied. So these are challenges in the future, but also promises that biofortification can be made more impactful. And of course, we have the blueprint of how to overcome these challenges. And as hinted earlier, it all depends on balancing these four elements. So we have a robust evidence base to advocate for policies and to advocate for further research. We have to continue to evaluate the impact of biofortification and the other interventions. We have to continue producing an enabling environment through policies, but also through raising champions from the ground up and networks that promote the implementation of biofortification in each of the countries. And aligning supply and demand is very important. Through supply of high quality seeds or growing material, the aggregation of the biofortified varieties so that consumers get what they are buying in their mind. And the demand side, of course, it has to be done through partnerships. It'll be the private sector. It would be the small and large farmers that will produce these crops, and education of consumers, like I showed they are doing in Nigeria, and engaging media and influencers as well. This is something that's being done a lot in India and in Nigeria, the two biggest countries where we work and the two biggest success stories to date. And so I think I will leave it there with enough time for questions, and the floor is yours. Thank you very much.
Thank you, Eric. It was wonderful and very resourceful. I'm going to start with the broader question before I get into detailed questions in the Q&A and the chat. Mm-hmm. The broader question is you start this biofortification program, as I remember, it was a long time ago. It's about 2 decades when I was a grad student that you were talking about this and you initiated, brought the money and did all these things. So within this 2 decade now, it's almost 20 years, climate has changed. But then you develop all these new varieties with the high iron, zinc, and also carotenoids. Are these varieties, are you guys going to keep it for a long time? How it manage with the climate change, or like, is there like the vision for the future to do more breeding on that side?
Thank you. Yes, the breeding happens at the CG centers and the National Agricultural Research and Extension Services for multiple traits at the same time. So climate resilience, abiotic and biotic stress resilience, those are the main non-negotiable traits that breeders are breeding for. And the nutrient trait is added to that. So yes, the breeding for climate resilience and others and resistant to other stressors continues. And I would dare say that breeding for climate resilience and not all these other non-nutritional traits continues to take precedence over the nutrient traits. And so that's really the hard part now that breeding is going to be mainstreamed and in the hands of the centers themselves, rather than HarvestPlus coordinating. That breeders will continue to do business as normal, right? And the risk there is that what happened with the zinc contents of wheat during the Green Revolution, which is that it decreased because they were breeding for short stalk wheat that happened to have less zinc and more starch. That this doesn't happen again, right? So in short, breeding will continue for all of these.
So
threats.
Maybe we need a second HarvestPlus, second 10-year phase of HarvestPlus for micronutrient enrichment with the climate resilience. It can be possible.
It's really not really possible because the donor environment is not supporting that. They want this to be handed over to the centers to make it a responsibility of the centers and countries to demand that as well to make it more sustainable. Yes, but
exactly. So, Erick, you want to stop sharing so that people can see your face? That's what I think.
I thought I had. Okay, no, here it is.
Yeah, that was a question. Okay. All right. So we talk about the climate resilience and we talk about the biofortification. So I'm sure this is another concern from the panel. And this question is, usually the increase in micronutrients in pulse crop is very, micronutrient in all the crops is very low using breeding strategies. Moreover, there is a trade-off between micronutrient increase and the yield. So this wanted to know, like this Dixit, he wants to know that what is your thought on this increase and the yield, how the correlation?
Yeah, well, that was the story 20 years ago, but that story has, from breeders mainly, has changed. You can maintain an increased yield and at the same time increase iron and zinc and provide vitamin A, except maybe for maize, because the maize hybrid, commercial maize hybrids, white maize hybrids, that private sector giants like Pioneer have produced have very, very, very high yields. But now we're also producing vitamin A maize hybrids that are, getting up there. But that's the only crop that doesn't always reach yields that are competitive with hybrids. But all the other crops are being successful because of their yield. Like I mentioned, the Pakistan zinc wheat variety, Akbar 2019, is now has 40% of the wheat seed market in Pakistan because of its yield advantage, not because of the zinc content. So
Right.
yeah, yield is a non-negotiable trait that must continue, and so a biofortified crops don't affect that. And the other thing you said was the levels of micronutrients are low, and that's relative because, as I showed in one of the slides with all the crops, and the percent contribution to the average requirements, orange sweet potato has very high provitamin A level.
Right.
Beans have very high iron levels, enough to meet daily requirements. Of course, not in every population, because if you don't need beans, well, beans won't work for you. Yeah, that's my short answer to that.
Yeah. So you're right. So like some of the lentil varieties with the high yield, plus they have high iron and zinc as well, because it's depending on how many number of genes that actually control that trait. So yeah, you're absolutely right about that. There is another question coming in. Actually, there's several of them. So there's another question. Why does India, having better economic and scientific abilities to perform the same levels of some of African countries with the same population densities? So the question is basically why India does a better job than Africa.
Well, India is investing more than the African countries. India invests a lot. India has its own biofortification program in the Institute of Biotechnology and different research centers throughout the country. India also has a law that's like 4 years old, whereby pearl millet varieties cannot be released without having a minimum iron level, which was
right.
Yeah.
Yes.
And so India is doing really well in that respect. Problem with India, I think, is that different regions of India consume different staples, right? The north consumes wheat, the south consumes rice, some states consume pearl millet, and so the varieties for India, except for pearl millet, haven't been able to reach the levels as, let's say, wheat zinc in Pakistan or zinc rice in Bangladesh. The breeding is going a little slower for those crops in India.
Right, exactly. So like Akbar 2019 is a fascinating story of a success. How can others to create success stories like that?
Yeah, well, the thing is, Akbar 2019 and a couple of other hybrids of wheat coming from Pakistan are being introduced in India, but you know how jealous India is about its germ plasm and its receiving or sending out anything. So it's being done in Odisha and Bihar right now, the testing.
Exactly. So and I 100% agree with you. Like we can do quite a bit of breeding to increase the nutritional quality or the nutritional content. It doesn't matter micronutrient or the macronutrients, but the policies from each government had to put something to bring a success story, because the money is important, because CGIAR centers has also a limited number of money. So therefore each country has to step into what they can do. I totally agree with you. And my last question is there a monitoring system for these genetic traits for future? Because these are conventionally bred. These are not GMO crops. These are conventionally bred, brought the traits into these new varieties. So is there a mechanism in place to see the validity of this trait over time? Because with the time, these traits can be gone away, right? So is there like a new research happening to test that?
Well, there's DNA fingerprinting, but that's too expensive for program purposes. I mean, but what's being done is monitoring the seed production. and making sure that the seeds that are being made available by seed producers, private or public, come from stocks of certified seed that are biofortified. And then seed sales are monitored, and seed planting and harvest of the crop is monitored only in the countries where we work, which 8 or 9.
Absolutely.
Yeah, because you know that monitoring is very hard for countries to fund, right? They don't see the benefit because they don't have the data use culture, right? Even if they generate the data, they rarely use it. So, but yeah, that's what we're doing. We're monitoring.
I hope this is something HarvestPlus would do, that for like your next phase or something like that, from the money from some sort of a to secure these genetic traits over time, instead of they just disappear over time. You know, like some new varieties will go away after 5 years because they are not going to produce the same yield and the same nutrient concentration. So I hope that some policy will change and HarvestPlus will continue to do their job to, hopefully you will have funds to do that.
Yeah, well, right now, because of the restructuring of the CG centers, the 13 centers around the world.
Right.
Yeah, we will have a role to play, but we will have to work with the centers in the mainstreaming, because mainstreaming makes sure that breeding for nutrients will continue, but somebody has to monitor that. And so we're now having to work with other nutritionists at the centers to screen the varieties that they are putting out and releasing in countries, you know, with simple technology, because otherwise it's not affordable.
Exactly.
So we are using XRF for minerals.
I see that. Yeah. This is wonderful, Erick, and I really wanted to thank you with my heart appreciation for you to doing this, because recently I did the data analysis from when the day HarvestPlus start and how the stunting and the wasting go down, actually correlation. I see a variety release time and the data go down, this burden in this country. So you
have to share that with me.
That is like amazing. I did that too for one of my talks to show how this breeding is how important. So it was like really, really impressive, the work that you do. So I hope HarvestPlus get funded and continue this great work to reduce the micronutrient malnutrition. Also, we can go a little bit beyond from micronutrient, adding protein, because it is coming with all this wars and social unrest in the countries, and they need more food. So I hope you can continue this great work. And thank you so much. I always say a lot of good things about you when I give a talk, because of the work that you do. So thank you so much for coming and sharing all your wealth of knowledge. And thank you all for joining today. And our next seminar is actually in the next year, 25, because Dr. Boyd's talk is the last talk for this year. I'm actually not in US, I'm traveling right now. And then we have very exciting talk in January from Dr. Thelma Valise. She will talk about how the organic system and bridging the gap between organic research and the organic growers. So we would love to see all of you. And until then, you will have a happy holidays, and we will see you all in 2025, January. Goodbye, everyone.
Goodbye. Thank you.
Thank you, Erick.